Strawberries have one of the strongest emotional associations of any fruit. People link them to celebration, desserts, summer harvests, childhood memories, and fragrance. But nearly everything you assume about strawberries is scientifically unusual, especially the fact that the seeds sit on the skin. Today, we break down how this happened and why this red fruit changed agriculture, cuisine, and culture. The strawberry, scientifically classified within the genus Fragaria, represents one of the most complex horticultural evolutions of any modern fruit. Unlike bananas, apples, citrus, or grapes, whose domestication pathways were gradual, the strawberry emerged through an accidental hybridization event in the 18th century involving two distant wild species. Before that moment, humans interacted primarily with wild European alpine strawberries, scientifically known as Fragaria vesca. These small, aromatic fruits grew abundantly in meadows, forest edges, and hillsides, and they were deeply appreciated not for size, but for taste concentration and perfume intensity. Medieval records describe them as a seasonal delicacy served in aristocratic courts, often arranged on leaves rather than bowls because the fruit bruised easily. The modern strawberry owes its existence to transcontinental botanical exchange. Spanish explorers carried Fragaria chiloensis, the Chilean strawberry, back to Europe. That species produced large but mild-flavored berries. Meanwhile, European gardens already held North American Fragaria virginiana, a smaller fruit with stronger aroma. When these two species cross-pollinated in France around the mid-1700s, their hybrid, Fragaria times ananassa, displayed the perfect balance, larger fruit size with heightened sweetness and fragrance. This hybrid would become the mother of all commercially grown strawberries today. The strawberry is structurally unique. The red flesh is not a berry botanically. Instead, the red material is a swollen receptacle, the structural foundation of the flower. The real fruits are the tiny seed-like bodies, achenes, embedded externally. Each achene contains its own miniature seed. This inverted architecture means strawberries are one of the few fruits that display their reproductive elements visibly. There is an evolutionary explanation. Exposing the seeds externally increases dispersal potential. As animals bite into the swollen flesh, seeds detach more easily, spreading across larger distances. Additionally, early wild strawberries were small and clustered. By placing seeds outward, plants reduced digestion loss, because animals rarely chewed each achene completely. Therefore, seeds survived better than buried seeds found in internal structures like plums or grapes. Pollination dramatically influences the strawberry's shape. Each achene corresponds to hormonal signals determining swelling tissue beneath it. If certain flowers receive incomplete pollination, fruit develops asymmetrically. This is why commercial growers rely on intensive bee populations. The consumer expectation for perfectly symmetrical strawberries is directly linked to honeybee labor. Without full pollination, strawberries deform. In terms of chemistry, strawberries possess unusually complex aromatic compounds. Over 350 volatile elements contribute to their recognizable scent. However, only a small number generate dominant sensory perception. Key compounds include methylanthranilate, ethylbutanoate, and furanol. Some cultivars express them at higher ratios, which is why heirloom strawberries taste stronger despite smaller size. Industrial cultivation significantly altered strawberry flavor. Commercial selection prioritized transport durability, thicker skin, uniform shape, extended shelf life, and disease resistance. These traits genetically associate inversely with aroma richness. Large commercial monocultures resulted in a sensory decline that consumers often notice, even when sweetness remains stable. The nutritional profile of strawberries centers around vitamin C density, dietary fiber, anthocyanins, ellagic acid, and beneficial polyphenols. Their pigment concentration, the deepest reds, typically correlates with antioxidant content. Wild strawberries possess more intense coloration per unit mass, hence stronger health compound presence. Culinary evolution occurred differently across regions. In Japan, strawberries entered dessert culture in the early 1900s, eventually forming the foundation of Christmas shortcake rituals. The fruit symbolized purity, celebration, seasonal beauty, and modernity. In the US, strawberry shortcake entered fairs, festivals, and regional food competitions. Strawberries became summer hallmarks, tied to agricultural ceremonies, farming pride, and community identity. Across Europe, strawberries linked with medicinal folklore. Early herbal texts noted their effects in soothing digestive discomfort. Medieval physicians recommended infusions of dried strawberry leaves. Strawberry farming transformed dramatically through vertical farming and controlled greenhouse environments. Today, hydroponic cultivation allows year-round supply independent of seasonality. Because strawberries are shallow-rooted, elevated tray systems optimize nutrient flow, water conservation, and fruit cleanliness. But this modern convenience significantly shifts cultural meaning. Historically, strawberries represented ephemerality, the brief sweetness of spring. Before refrigeration, seasonality defined anticipation. Now strawberries are mass-produced, standardized, and available continually, reducing symbolic value but increasing accessibility. At a horticultural level, strawberry plants demonstrate self-propagating efficiency via runners, horizontal shoots that form genetically identical offspring. This clonal strategy allowed rapid agricultural expansion throughout the world. Yet wild strawberries remain botanically distinct. Smaller fruits possess stronger perfume, shorter shelf life, softer pulp, and quicker oxidation. Their flavor, though fleeting, often surpasses commercial varieties in aroma depth. Botanists continue developing cultivars to restore sensory quality without sacrificing durability. Modern breeding aims for complex sweetness, acidity balance, floral fragrance intensity, juiciness retention, and visual brilliance. Today, the strawberry stands as the most widely recognized fruit symbol in food marketing. Its shape represents celebration, freshness, dessert, romance, childhood, and seasonal joy. Yet behind the cultural imagery lies a botanical structure so unusual that it challenges ordinary classification. The strawberry remains one of nature's most elegant intersections between biology, flavor chemistry, historical globalization, and ritualized seasonal enjoyment. Its relevance persists not just because of sweetness, but because strawberries embody anticipation, tenderness of flavor, memory, and fleeting harvest cycles transformed into a global industry.